Right. We early on felt that the anti-aging vitamin might be a nitrate, and we spent quite a bit of time investigating different nitrate molecules, and eventually we were able to eliminate the nitrate hypothesis, really based on the problem of how would the flood have changed the concentration of any given nitrate in the environment. We weren't able to answer that question successfully. We couldn't see what the flood might have done to change nitrate concentrations. So we threw that hypothesis out after we had probably been investigating it for, I don't know, maybe a year and a half or 2 years. We had synthesized various nitrates in the lab. We had tried them out with mice, or were in the process of trying them out with mice. And so again, the whole process of determining the correct anti-aging molecule is a laborious, lengthy process. You're not just looking at one particular trait, you're looking at a whole bunch of traits in a lot of different ways. It's chemical behavior, it's environmental behavior, and so forth. We also, for a period of time, we looked at a lot of the compounds that come from isoprene. Isoprene is the most abundant organic molecule in the atmosphere. That is to say, trees and whatnot produce isoprene. They put it off into the atmosphere, and then in the atmosphere it goes through a chemical reaction in the atmosphere, a bunch of chemical reactions, breaking the isoprene molecule down into pieces and forming all kinds of different other smaller molecules, all of which could potentially have been the molecule we were looking for. Ultimately, we falsified the isoprene hypothesis after we had synthesized numerous isoprene fragment molecules, and after we had tried them out with mice and so forth. And again, the modeling studies always were helpful in showing whether these fragments would have the right kinds of solubilities in ocean water and the right kind of reaction in the atmosphere to stand as viable anti-aging vitamin candidates. Ultimately, one by one, they were shown to be inadequate, and after a few years, moved on to another compound. And each time we do this, we get better at it. We get better at picking a potential candidate that might have the right properties to be the molecule that we're looking for. The whole process of finding the right molecule is a problem right from the outset, you can see, because there are essentially an infinite number of molecules that you're starting with, and you're trying to sift through this great huge stack down to the one which is responsible for aging. A huge task, and lengthy, and requiring all the skill and determination of the best detective to be able to ultimately get down to the right answer. Yes, there's actually quite a bit of overlap in terms of the experience of failure. Each failure is a stepping stone toward ultimate success. Of course, you're not guaranteed success. You may just have a string of one failure after another and never really get to the answer that you're after. I read about Edison that he said that he now knew 1,000 things that wouldn't work, so that he had learned something in the process. It wasn't like it was a total washout. This is the way research goes. You adopt a hypothesis, you critically examine it against all of the available evidence that you have to that present time. When the hypothesis fails, it fails for some reason. In Edison's case, he would have been trying hypotheses like, well, let's see whether copper wire will work as a light bulb filament. And so he then sets up his apparatus with a piece of copper wire between other wires inside of a light bulb glass with maybe argon in there or something, so the oxygen doesn't just immediately burn up the wire. Turns up the current and the thing starts to glow, but before it has glowed very long, it melts and there's no light. He, at that point, knows that copper won't work, but he also knows why it won't work. It wouldn't work because the melting temperature was too low. And so he knows he must find some material which has a higher melting point. And so he starts restricting his search for new possible light bulb filaments to things that have a very high temperature melting point. The same thing happened in the search for the missing vitamin, the vitamin responsible for aging. We would adopt a candidate substance. Based on everything we knew to that point, we would say, well, this particular molecule looks like it might do the job. Let's see if it works or not. And then we model it, we examine it from every angle, what the biblical history tells us about what happened with aging. We look at it from a chemical standpoint. Does it have the right kinds of properties? Does it have the right solubility? All kinds of things. And time after time, the answer was, well, it works to a certain point, and then it fails. It's not able to answer the next question. And so then you say, well, what can we now find another candidate which is better than this one that we just tried, that won't have the problem it had? And that usually takes some searching around, scratching one's head, feeling like, wow, maybe nothing's ever going to work here. And then, lo and behold, you've come up with another candidate, and you then again begin to subject it to the same scrutiny, trying to answer these questions. Does it fit what the Bible tells us about how people were dying of aging in the past? Does it fit with what we know about the environment and what would have had to been happening with this vitamin in the environment? So you're screening or you're sifting. And the process of sifting went through a dozen or 2 dozen, not 1,000. I was not as bad off as Edison. But the problem was that the investigation of each new candidate was a much, much more laborious process than the investigation of a new potential light bulb filament. So it was a lengthy process.